This video is on the objective solve applied problems with the law of cosines. So you see the words applied problems, this means word problems, and for most of these I've noticed they're drawing a picture for you of some triangle. You may have to draw your own picture in some cases, but for most of these you'll have your own, a picture drawn for you. Let's take a look. And again, if you want to see more about this, what they're saying about this objective, click on More Instruction, look at their notes, their videos, their examples. Hopefully those help you out. So here, an airplane started at point X. Right, so started at point X. Traveled 320 miles to point Y. Right. Adjusted its route and traveled another 400 miles to point Z. If the airplane is currently 599 miles from point X, by how many degrees did it adjust its route at point Y? Round your answer to the nearest degree if necessary, and do not enter the degree symbol. Alright, so look at the picture. They want to know this, again, the airplane's heading toward Y here, and then it turns so many degrees and heads towards Z. They want to know how many degrees is this turn. Well, that's outside the triangle, but if we find this angle Y inside the triangle, then we can just subtract that from 180 and get this, right? Because these two together will make 180 degrees. They'll be supplementary. Alright, so I'll draw this picture and we'll go about solving this problem. Okay, so I have a case here where we have a side, side, side case, right? A side, side, side triangle, SSS. Because I know all three side lengths here. The distance here is 320 miles, 400 miles, and 599 miles. And I'll call these something, right? The way they're typically labeled is, the angle measures or some capital letter or some Greek letter. And then the opposing sides are like the lowercase version. So if that's angle Z up here, then this will be side Z, little z. This is angle Y here. This is angle Y here. And the side opposite, the 599 miles, that'll be side little y. And then angle X here, so this side here, the 400 miles will be little x. Okay. Now remember, in the side, side, side case, you want to find missing pieces. What I'm trying to do here is I'm trying to find this orange angle Y that the angle Y inside the triangle. And then the question mark plus this angle Y, those will add up to 180, right? They make a straight line, a straight angle. They're supplementary. Now in the side, side, side case, to find a missing angle measure, you're going to need to use the law of cosines. All right, and in this case, I want to find angle Y. So I'm going to start with the y, little y squared. Right, the version where, again, one side squared equals, and then a bunch of stuff. Right? And it starts off like the Pythagorean theorem, where you have one side squared equal to the sum of the other two sides squared, so little x squared plus little z squared. But then there's a little more to it. Then you subtract 2 times the product of those sides, right? So 2 times little x times little z, times the cosine of this angle opposite this side. All right, the angle that's opposite the side I started with on the left side here. So if y squared equals, x squared plus z squared, and then this big product here at the end minus, 2 times x times z times the cosine of angle y. Now, if I'm trying to find angle y, right, I'm eventually going to need to get this cosine of y by itself. So hopefully you can follow the algebra here. What I could do is I could add the 2xz cosine y, subtract y squared, and then divide by 2xz. And that'll get the cosine of y alone. So we can get this. This is another version of the law of cosines if you want to solve for the angle. So the cosine of y, again, if you follow the algebra I described, I'm not going to write out all those steps, would be x squared plus z squared minus little y squared, then all of that divided by the 2xz. And so again, I took this term, added it, subtracted the y squared, and then divided by 2xz to get the cosine of y alone. And then to find angle y itself, I just take the inverse cosine of both sides, the inverse cosine of this expression. So I can tell you right now what I'm going to punch into my calculator to get the angle y there. So angle y is going to be the inverse cosine of the following fraction. Now x squared would be 400 squared plus z squared, 320 squared, minus little y squared is 599 squared, right? That's all in the numerator, so I'm going to put like parentheses around that in my calculator. And then again, parentheses around my denominator when I enter it in the calculator. 2 times x times z, 2 times 400 times 320. So this is what I'm going to enter, and I'm in degree mode here. They want things in degrees. So this approximately, now I'll pull the calculator up. Make sure I am in degree mode, which I am. And enter all this. We got the inverse cosine, and then my numerator in parentheses. We have 400 squared plus 320 squared minus 599 squared, right, and close that off, and then divided by, now this is all still inside the inverse cosine. Then in the denominator I'll put a set of parentheses around this product. 2 times 400 times 320. And then close the parentheses on the denominator, and then close the parentheses on the inverse cosine. So this is approximately 112 degrees. They asked us to round things to the nearest degree. So if this, right, that's the angle inside the triangle here. This is about 112 degrees. So then this question mark, the amount of turning, how many degrees did the plane turn to move toward point Z, that would just be the supplement. Right, so this, if that's about 112 degrees, then this is about 68 degrees. And this is what they're asking for, right, the question mark. So, the plane's traveling this way, right? Say that's a plane. Ooh, that's a terrible plane. Traveling this way, traveling this way, traveling this way. And that would have to turn, 68 degrees to head toward point Z. Right? If these are all the true distances. Okay. So back here I'll enter 6. Now they didn't say put a degree symbol, right? Just 68. Great. Right, now they use C instead of Y and A and B instead of X and Y for some reason, but it's the same setup, using A, B, and C instead of X, Y, and Z. All right. Wonderful. So again, hopefully watching me do this, reading the more instruction when you can, looking at the answer explanations when they come up. Hopefully all this stuff helps you when you're going about this on your own. And thank you for watching.